So here's the dilemma, right? Paying, say, $20 a month for what's supposedly the absolute best AI, or getting something that performs almost identically, maybe even better in some ways, but it's free and it's open source.
Yeah, that's really the core tension in AI right now, isn't it? And this isn't just, a small saving. It feels like a fundamental shift is happening. A new model has just shot up the rankings.
Welcome to the deep dive. Today we're looking closely at Kimi K2 Thinking. This model has kind of quietly blown past almost every big name closed source competitor in head-to-head tests.
Absolutely. So our mission today is to really understand how. How did this open source model climb to number 2 globally? It's apparently just 1 point behind GPT-5, which is kind of wild. We're going to break down the tech, look at what it means for businesses, especially its reliability, because it's doing amazing things with financial analysis, expert coding, really complex stuff.
Okay, let's unpack that shift, because it really does feel like another DeepSeek moment, like the courses call it, where suddenly open source isn't just catching up, it's setting the standard.
The ranking itself is genuinely staggering. Artificial analysis has Kimi K2 Thinking ranked number 2 in the world. And we're not talking about it beating some niche models here. It's leaping over the giants.
Like who? Let's name them.
Okay, so it's outperforming Grok 4, that's XAI's big one, Claude 4.5 Sonnet from Anthropic, and Gemini 2.5 Pro from Google. Just a few months back, the feeling was, the absolute top tier. That'd always be proprietary, always locked behind huge R&D budgets. Now you've got a zero-cost option delivering intelligence that's knocking on GPT-5's door. That changes the whole equation if you're building things, right?
It really does. And when you see that tiny gap, just 1 point behind GPT-5, the open source part becomes the killer feature. You're getting, what, like 99% of the capability, but without the vendor risk.
Exactly. And think about the practical side. If you're running a dev shop or maybe handling really sensitive data, now you can potentially run this model on your own servers, your private cloud. You keep complete control over your data. That's something you just don't get with most of the big cloud APIs.
And the cost predictability must be huge. API fees can jump around, scale in ways you don't expect. Getting rid of that line item, that's gotta feel good.
Oh, totally. Imagine the budgeting relief. You know your server costs, roughly, but you ditch those massive, sometimes unpredictable API usage fees. It just shifts the power away from, the handful of big tech companies controlling the best models.
So zooming out, what would you say is the single biggest practical win for a business when a model this smart goes open source?
I'd say it's freedom.
Yeah.
Freedom from being locked into one vendor and those high, kind of unpredictable API costs.
Okay, let's pivot from the rankings to how it actually performs. Coding seems like a great place to start because that's often where these models show their limits. The source material kicks off with a wild challenge. Build a drag-and-drop website builder, kind of like Wix, but from a single prompt? That sounds ambitious.
Yeah, it's a serious test of, structural reasoning. It's not just spitting out some static HTML. It needs to understand interaction dynamic elements. And Kimi K2.
Yeah.
It delivered a fully functional editor, just one HTML file. It really seemed to grasp the underlying logic needed.
So it had to plan out the JavaScript, right? The dragging, the dropping, handling the over events, plus the CSS for styling, and make it all work together smoothly.
Yes. And the little details, too. It had working side panels, elements you could actually drag around, and importantly, a snap-to-grid system, with the little red lines showing alignment, getting all that right in one shot from one prompt. That's really, really rare for this kind of complex application.
Okay, the next test sounds even harder. The fluid dynamics simulation, that's straight up expert coding territory. You need physics, math, animation, all interactive.
It's a real synthesis task. The model has to plan the physics simulation itself, managing particles, pressure, velocity, all that, and then translate that complex math into fast JavaScript that renders in real time on an HTML canvas. And the result was interactive. You could tweak sliders for viscosity, diffusion, and the fluid actually behaved like you'd expect. It looked realistic.
Now, here's where it gets really telling, I think, about this open source parity idea. The sources point out that Grok 4, Claude 4.5, Gemini 2.5 Pro, run at all.
Right. And Kimi K2 and GPT-5 were the only 2 models tested that actually nailed it. That could build this complex, physics-based, interactive thing successfully. That's the takeaway you really need to absorb.
Just imagine the complexity behind that. A system that gets the deep math of fluid physics and knows how to implement that efficiently in JavaScript, rendering it smoothly, all from a text prompt. That's something else.
Yeah. It means we basically have 2 models now operating at that peak level for expert code generation. and one of them is free to use.
So how does Kimi K2 passing that fluid dynamics test really change the game for evaluating model complexity?
It proves Kimi K2 isn't just good, it truly competes at the highest level of expert coding, even across different disciplines like physics and web tech.
Before we get into maybe where it stumbles, there was another big win mentioned, right? The 3D geospatial visualization of Tokyo that also shows off its knowledge base.
Yeah, and they did something important there. They turned off web search. So Kimi K2 had to use early its internal baked-in knowledge. And it correctly placed neighborhoods like Shibuya and Asakusa on a 3D map. It added building extrusions, used Mapbox GLJS correctly, even added a day-night toggle. All from memory, essentially.
That shows it's not just applying code patterns, it has actual world knowledge integrated pretty deeply. That's knowledge plus application skill.
Absolutely. But, okay, to be balanced, we need to look at the edges. Where does GPT-5 still have that slight advantage? That brings us to the beehive simulation.
Right, another super complex test. This needed specific biological knowledge about how bees build hives, combined with tricky geometry, those hexagonal cells, foraging patterns, interactive controls.
And Kimi K2 did build a simulation, which honestly is still impressive. You could see cells forming, bees moving around, but the hexagonal alignment was off. Critically flawed, actually. The pattern wasn't regular like a real honeycomb. The hive grew kind of chaotically, not in that structured, layered way you see in nature.
But GPT-5 got the geometry perfect. Stable, mathematically correct hexagons.
Apparently, yes. GPT-5 nailed that part.
So if Kimi K2 can handle the complex math of fluid dynamics, why would this specific geometric pattern trip it up? That seems counterintuitive.
It's subtle, isn't it? I think it gets into the nuance of these models. Fluid dynamics, while complex, is heavily based on known equations. You apply the formulas. Achieving perfect geometric precision in a complex simulation like the beehive, that seems to need a different kind of extreme attention to detail. To coordinate systems, object relationships, maybe it's just harder to specify perfectly in a prompt.
You know, I still wrestle with this myself sometimes. I find myself expecting absolute, almost scientific perfection from these single prompt outputs, even when they're incredibly complex. It's easy to forget they're working from learned patterns, not some fundamental understanding of mathematical truth, you know?
That's the vulnerable admission, right? We all kind of do that. And these small failures, like the beehive alignment, they're useful. They show us precisely where the current limits are, and where careful prompting and maybe multi-step generation are still key.
So why is understanding these little stumbles, like the beehive example, just as important as celebrating the big wins?
It highlights where GPT-5 still holds an edge, particularly in tasks needing extreme geometric precision and intricate detail.
Okay, really interesting. Let's take a quick pause here. When we come back, we'll dig into what might be the ultimate test for professional use. Can you actually trust it? We're talking reliability, zero hallucination, especially in high-stakes areas like finance and scientific research. Welcome back to the Deep Dive. We're talking about the open source model Kimi K2 Thinking. So for any business, any researcher listening, reliability is paramount, right? A cool demo is one thing, but if the output isn't accurate, it's useless, maybe even dangerous. Let's get into that financial analysis use case mentioned in the sources.
Yeah, this sounds like a killer app scenario because it tests really deep reasoning across multiple dense documents. So they fed it Q4 financial reports, think thick PDFs from Google, NVIDIA, and Amazon. And the task was compare them, create charts, pull out key insights.
That's tough. It's not just summarizing one doc. It has to find the same metrics across different report structures, different accounting styles, and pull exact numbers correctly from all of them.
And the results. According to the source material, the accuracy was shocking. It nailed YouTube ads revenue, $10.5 billion.
Correct. It correctly pulled out NVIDIA's absolutely insane 12,264% year-over-year growth. Correct. The claim is the numbers were 100% right across all three of these super dense reports. I mean, that level of precision, synthesizing hundreds of pages, that could save a financial analyst days of manual grunt work.
Okay, so if it builds trust in finance, what about really specialized science? It was tested on researching Alexander disease, a rare neurological disorder.
Right, and here it apparently used its thinking and search modes, which
Right.
sound agentic. Agentic basically means the model doesn't just respond, it can plan and execute steps. Like a human researcher would. Okay, I need to search for papers, read them, synthesize findings, structure a report.
And the quality of that final report after it processed, 48 different research results? The claim is publication quality. It apparently generated detailed flowcharts mapping out the molecular pathophysiology, a clear diagnostic pathway. And crucially, It included a timely update about an expected FDA filing for a potential treatment in Q1 2026. That's not just summarizing old info, that's pulling cutting-edge, relevant details. Super sophisticated synthesis.
Wow. Okay, and then the ultimate acid test for trust, the
Yeah.
hallucination trap. They asked about Stable Diffusion 5, which doesn't exist.
Exactly. This is a classic failure point for LLMs. They often just confidently invent plausible-sounding details about things that aren't real. But Kimi K2 passed perfectly. It didn't invent anything about SD5. Instead, it correctly stated it doesn't exist and provided accurate info on the actual current version, SD3.5. That kind of reliability, refusing to just make stuff up, that's absolutely critical if you're going to use this in a professional setting.
hmm And the sources also mentioned quick hits like successfully creating an interactive gut bacteria taxonomy tree,
Yeah.
quite niche, and an interactive physics course that perfectly modeled kinematics. So the picture emerging is one of reliable, sophisticated, and importantly, trustworthy performance in complex domains.
So given that stellar performance in finance, science, and the hallucination test, what's the biggest hurdle left for companies wanting to adopt Kimi K2?
Probably scaling its deployment, right? And
Right.
integrating it smoothly into their existing workflows and tech infrastructure. So let's try to wrap this up. What Kimi K2 seems to represent, it feels like a really significant, maybe permanent shift in the AI power balance. It's clearly a powerhouse. It offers capability that's right up there near GPT-5, but it's free, it can be run privately, and it's proven capable of generating complex working apps and highly accurate analysis in demanding fields.
Yeah, the strategic takeaway for anyone listening, developers, business leaders, is pretty clear, I think. Open source has definitively closed the quality gap with the top proprietary models. You might no longer have to choose between the absolute best performance and having control over your data, your costs, your infrastructure. That choice is changing.
And the source material hints that part two is going to dive into the tech specs specifically. It's 1 trillion parameter mixture of experts or MOE architecture. That MOE approach is probably key to how it achieves this performance while staying, well, manageable enough to be open sourced.
Right. So maybe here's a final thought for you to chew on after this deep dive. If a free open source model can already do this, what happens next? What happens when the cost of the hardware needed to run a model like this drops low enough that basically every small team, every consultant, every startup can have their own private, powerful, maybe even custom-tuned AI? That feels like the next wave of disruption coming.
Definitely something to think about. Keep digging.